In this lecture, we're going to look at a few other things you can do in your conditionals and in your loop constructs in Java. So thus far we've looked at three different kinds of loops in Java: the for loop, the while loop, and the do while loop. And I'm going to show you two new statements you can use in the bodies of those loops. You can use a break statement and you can use a continue statement. Now these are optional things. You could always do things using just what you currently know about loops, but often it's convenient to use break and continue, and certainly if you read other people's code, you're going to see code that uses these two statements. We're also going to look at a new conditional called the switch statement, and the switch statement is kind of like a big if else statement, and the switch statement just provides kind of a more convenient way to package up a big conditional that does one of many different options. So starting with the break statement, here are two while loops. The while loop goes from 0 up to but not including 100, and here's a for loop that does exactly the same thing. If you put a break statement in the body of your loop in some spot, what happens is that causes the loop to immediately exit. You do not execute any more code in the loop body. You do not go back up into the for loop, check the condition, or perform the increment or anything like that. It's terminal for that loop, and what will happen is if you're somewhere in this while loop, you hit a break statement, it's going to drop the code execution down to the statement that follows the curly brace of the while loop. Same for the for loop. Whenever you use a break statement, it's going to break the loop that immediately encloses it. So you can imagine we could have a nested structure. So we might have a for loop. Maybe this for loop's inside of another for loop. If there's a break statement in the curly braces of this inner for loop, it's going to break just this for loop and not any other enclosing loop. Here's a sample program, and maybe we haven't seen this before. Here's a way you can declare, create, and initialize an array in one line. So like normal, we declare the data type of the array. It's of type integer. Alright, we've got the square brackets indicating it's an array, the name of the variable, and we can set it equal to a list of things inside of curly braces. This tells Java that there are going to be 7 things because there's 7 things in this comma separated list, and it also tells them what the initial values. After executing the statement, we'll have an array data. It will have 7 elements. Data bracket 0 will be 1, data bracket 1 will be 2, and data bracket 6 will be 0. There are a couple missing lines here, while and the condition of the if. The goal of this program is to go through that array and sum up all the numbers. If it encounters a negative number, then it should just print out invalid data. So go ahead and pause the video and see if you can write down what should be in these two spots. Here's the answer. The while loop has a I less than data.length. So remember, any array always has a .length property, and the .length property in this case is going to be 7. We go while I is strictly less than, so that's important, strictly less than data.length. We'd never want to try and reference the data.length element of the array. Since we count from 0 in computer science, this is data 0, data 1, data 2, data 3, data 4, data 5, data 6. And so the while condition is while I is less than data.length. And as you may have guessed, given we're on a slide about the break statement, the second missing part is actually that break statement. We can go ahead and run that in the debugger. So we've got the same program here in the Eclipse debugger. I've set a breakpoint on the first line, and we'll run it in the debugger. We've initialized the data array, initialized I to be 0, sum equal to 0. Are we going to continue in the for loop? Yes, because I is less than data.length, and data.length is 7. First element, data 0, the 1, is that less than 0? Nope. So we go ahead and sum it. increment I by 1, go to the next element. That's also not less than 0, so it's okay, and we sum it, and we carry on through. What are we at now? We're at I equals 3, so we're at 0, 1, 2, 3. We're at 5. We're going to add 5 to our sum 13, getting us 18. Increment I. Now we're on that bad one. We're on I data bracket 4. This is in fact negative. We hit the break statement. That's it for the loop. We're out of this loop. We drop down to the next statement. And notice how this if works. If we were not to break this loop, the only way out of the loop would be to fail this condition in the while loop. And the way this would fail is once I is equal to or greater than data.length. If I is less than data.length, then we know for sure what happened is we hit that break statement, and thus we can go ahead and print invalid data. I don't know how we got to that switch slides there, but the other statement you can use inside of a loop is the continue statement. This does not cause the loop to exit, but what it does do is skip the remaining lines in the loop. If, for example, we wanted a program, this program loops through the data but does not sum the negative values, but it will sum all the other values. And as you might guess, so you can pause the video and try and figure out what should go in that position. Bit unsurprisingly, it's the continue statement, right? We're on a slide about the continue statement. This will cause the loop just to loop back around. It will go back up here, do the increment, and do the conditional test of the for loop. And we'll keep doing the for loop. It just does not execute the sum plus equals line in that case. We can see that in this example program. Let's run it in the debugger. It's going to come through here, and it's going to run that sum plus line for those items. This is the item that's negative. It's just going to go to continue, loop back up here, increment its I. I is still less than the data length, so it goes ahead and runs it on the rest of the data. I is now equal to 6. Comes up to the for loop, increments that I. I is now at 7. That's the end of the for loop, and then prints the answer. The last thing I'm going to show you today is a different way to do an item out of a set. This is a different way to do this. So imagine we have a variable called day. It's an integer. It's between 1 and 7. And our goal is to convert that numeric day of the week into a string. And we've got some variable called month str, and we want to set it equal to the actual day of the week spelled out, Monday through Sunday. If that day code is incorrect, we're just going to set it to the error message invalid day. And this is how you could do it with an if, else if, else statement. Nothing wrong with that. The switch statement provides you a different way of doing that same code. Here's the code using a switch statement. The way the switch statement works is you put the keyword switch, and then in parentheses you put the variable name, and that variable must be of some sort of integer type, like an int. In newer versions of Java 1.7 and above, you can also use a string variable in there, and we've put that integer value we're comparing it to. So this is like the if day equals 1 part, and this is like the else if day equals 2, and so on. And this final default case is like that else. You don't have to have a default case, just like in this if else if. You don't necessarily have to have this final else if you don't want. The case always is case and then the number colon the code you want. In this case I have a single statement, but I'll show you another example where there can be multiple statements inside of the case statement. And then importantly, there's always a break statement. So this denotes between the case and the break is the code block associated with one of those cases. And we can go, I've got this program in my Eclipse. If I can get back to Eclipse, there we go. Here's a program that takes the first command line argument and converts it to an integer. Let's see what integer we've got set here. 3. Go ahead and run that in the debugger. Starts up, converts that integer or that string variable on the command line to a integer 3. Initialize the variable month str, which is blank. It's going to drop in here, and it's just going to execute this line of code. It hits a break statement, so just like the break in a for or a while loop, the break statement causes the end of the switch case statement, and we jump down to the bottom and print it out. You can have more than one statement inside of here, and you don't have to use a curly brace. Here's an example where we have a direction variable, and that direction is going to denote, like, say, whether our avatar in our game is moving north, south, east, or west. We're going to switch on the direction variable, and then we have a case statement for each of the 4 cardinal directions. And depending on which direction, we're going to decrement or increment our x and our y variable that represent where our player is in the game, for example. If the direction was 0, it's going to go into the north block, it's going to execute y minus minus, and it's going to do the printout, and then it's going to break out of the construct. Here's a buggy version of the same thing. So do you notice what did I remove? I took out that break statement. This is now going to print out, instead of before it was just printing out, it would just print out walking north for this example code. And in this case, it's going to print out walking north, but then walking south, east, and west, because it's actually going to execute all 4 of these code blocks. If you forget your break statement, it falls through to the next case. And I can show you that. If we were to break our program by removing the break, remember case was 3 in my example. If we run this in the debugger, watch what will happen. So day is equal to 3. We drop into that case. We go ahead and we do the proper thing, which was set that string equal to Wednesday. But now we've forgotten our break statement. We fall through to case 4, run that code, and then we incorrectly print out the day as Thursday. Switch statements are nice, but you've got to remember to put in your breaks. It will not generate a warning or a compile error if you forget it. And here's me saying that in an animated form. Always be sure you include your break statement unless you want it to fall through the next case. And here's an example where maybe you do want to do it. If we have other directions like northwest and northeast, maybe we always want to run the same code regardless of whether it's northwest, northeast, or north. And so here's a common way you might see that when you look at other people's switch code. We've got 3 case statements. The first 2 don't have any code, but they will just fall through to the next case, and it will just keep running code until it's a break statement. So essentially what we have here is like kind of an if action equals northwest, or action equals northeast, or action equals north. But it's kind of a nice compact way to do it. So to summarize, today I showed you a few extra tricks you can do with your loops and a new kind of conditional. So if you're in a loop, you can have a break statement, and that break statement is the end of the loop. It will drop the loop down to below its curly brace without going back and doing an increment if it's a for loop or anything like that. Handy way to get out of a loop early. The continuous statement is a handy way if you don't want to run the rest of the body of the for loop for some reason. It will just skip the rest of the body and then go ahead and keep looping if the loop condition remains true. And then finally I showed you the switch conditional statement. It's a nice way to select an action from a set of actions instead of using something like the if-else-if construct.